This lecture is going to be on the different types of climate and their characteristics. There are three main climatic zones: tropical, mid-latitude, and polar. Tropical climates are from about 30 degrees north, 30 degrees south. Technically, it's 23.5 to 23.5 north and south because that's the tilt of our Earth on its axis. Mid-latitudes then 23.5 to about 66.5. On the previous lecture, I just rounded it to 30 and 60. And then the polar climates are going to be above 66.5 degrees north and south of the equator. Okay, so we still have our three main zones. There's our tropics, our mid-latitudes, and our polar regions. Within those three regions, we can break down the climates a little bit further. Typically, our mid-latitude climates have a lot of variations. The United States is pretty unique that we have a lot of smaller climates within the United States itself. The tropics don't have as much variation, and the polar regions don't have as much variation. So within the tropical latitudes, we can have the tropical rainforest. They're typically between 5 degrees south and 10 degrees north. They have heavy rainfall, about 250 centimeters per year. High temperatures, but a small range, only about a 3-degree range. And they also have high humidity. Examples, Panama and Brazil. They receive the most amount of direct sun rays because it's near the equator, so that's going to give it its hot temperature. Plus, it's at a low pressure system at the equator, so that's going to give it its rain. Here's a map showing you the distribution of the tropical rainforest. Notice how, again, they're all typically around the equator. My family and I took a trip to Guatemala and Belize. So this is in Central America, so this is considered a tropical rainforest. Tropical rainforests have a lot of adaptations. Some trees adapt by growing really tall so that they can reach the sunlight at the top. Other plants, like this big leaf, they grow their leaves really big because they're near the bottom of the rainforest, so they need to collect as maximum amount of sunlight as they possibly can. This is that same white tree that I just showed you in the last slide. You can see it towering above the rest of the rainforest. You see other plants take advantage of its height, the vines and moss, they will grow up top. We climbed up to one of these little temples and looked out over the rainforest, and you can see some temples popping up. This was another little temple that they excavated. So the rainforest literally covered it up. You can still see it on the sides. But they removed all the vegetation so that we, or humans, or visitors could see it. This is just a fun little picture. The one and only time that I got cornrows. It was an interesting experience, fun. We went hiking through the rainforest, and my dad brushed up against a poisonous tree, which is interesting. He brushed up I don't remember the exact tree it was, but he brushed up this tree and within hours got this big reaction. And we were hiking with a guide through another portion of the rainforest, and just by looking at his arm, he's like, I know exactly what that is. And he found another tree that was a remedy for this. And within an hour or so, my dad's arm completely cleared up. Tropical savanna, typically between 10 and 20 degrees north and south. It's sort of like the Lion King, where you have a rainy season and dry season, where we have the zebras, a lot of grassland. It's known for having a very wet season and a very dry season. So some examples, the Amazon basin, the Congo basin in Africa, and this wet and dry season is very favorable for grass, so we have a lot of grasslands and grazing animals. We can have a tropical desert. We have different types of deserts. So the tropical deserts are located between 20 and 30 degrees north and south latitude. Annual precipitation, 25 centimeters less. Remember what a rainforest was. Rainforest was 250 centimeters. Tropical desert is less than 25. They're noted for being very hot and dry. They're typically located at a high pressure system around that 30-degree latitude where we have sinking air. Examples, the Sahara Desert, Arabian, Thar, and Kalahari Desert. So there's a Sahara Desert, the typical camel scene. Moving up to the mid-latitudes. Like I said, mid-latitudes have a lot of variation. There are 5 subcategories for your mid-latitude climates. Taking a look at the United States, the marine west coast, so it's typically going to be, this is the windward side of the mountains. So we have this cool, moist ocean air coming off the ocean because we live in the westerlies. but we have a mountain range here. So this is typically wet. Mediterranean is often found in California. Highlands, those are going to be your cold mountain tops. Mid-latitude desert, southwestern part of the United States, and the mid-latitude steppe. Humid continental. We live in the humid continental and the humid subtropical. If you go farther to the south, we have this more warm maritime tropical air mass coming up, so this is going to be typically more humid than the northern half of the United States. So the marine west coast is between 40 and 60 degree latitude. This would be like Washington, Oregon State. And again, it has that cool mist maritime polar air mass coming off of the ocean, the North Pacific Ocean. They'll get between 60 and 150 centimeters of rain a year. They're noted for having cool summers and mild winters. They have cool summers because they have a cold ocean current flowing off the coast. And again, those mild winters are attributed to that ocean water. This is the Pacific coast, Oregon, I believe. We're near the coast. This is probably July. So notice we're in long pants and long sleeve shirts because it was a cool July day. And we have a lot of mist. It's very foggy here because that's the mist coming off of the ocean. Also another scene at the ocean here, very misty and foggy. There's a mountain range here you see. As the air comes off the ocean, it's going to rise up that mountain and form clouds. Same location. Now we see the clouds have cleared down below, but as soon as that air rises, we form clouds up here. This is Redwood National Park in Northern California. This is known for having the largest trees of the world. By large, I mean the tallest. There are Sequoia National Park that they're known for having the widest trunk trees. So it's almost like a temperate rainforest. It gets a lot of rain, and that allows a lot of the vegetation to grow. It is relatively cool still. Again, this was summertime. We're in long pants and long sleeves. Another picture of redwoods. I highly suggest going here if you can someday. The moist air allows a lot of moss growth. Olympic National Park in Washington State. Again, you can see the misty, sort of foggy look to the air. Again, all that mist and fog allows for a lot of moss growth. This moss growth can be seen in Olympic National Park in Washington State. Mid-latitude Mediterranean climate. This will be southern and central California between 30 and 40 degree latitude. They're noted for having a lot of dry summers due to this subtropical high pressure system and wet winters due to a pressure belt shifts and bringing cyclones. So these high and low pressure systems are not located at specific latitudes, but they're sort of semi-permanent. They will come and go with the seasons. They get about 40 centimeters of rain, which typically all comes in the wintertime. Mid-latitude desert and steppes, they're between 35 and 50 degrees north latitude or south latitude. These are found in the northern interior of the North America and Asia. Again, we're seeing those desert-like rainfall, less than 25 centimeters of rain. This is different from the tropical deserts. Tropical deserts are hot year-round. Mid-latitude deserts have cold winters. They can get snow in the wintertime. That's a common misconception. Typically, we get a lot of cacti and shrubs in mid-latitude deserts. So the Grand Canyon is part of the mid-latitude deserts. If you look down, you don't see a lot of vegetation. Here's the trail that I hiked down, sort of zigzags down. This was, I want to say, late May. It was still relatively cold. We were at a higher elevation, not as high as the North Rim, but it was chilly at night. We started hiking in the morning. Notice we're in long pants and long sleeves. It does warm up throughout the day, but this time of year it does get cold at night still. This was the Grand Canyon on the North Rim. There's still quite a bit of snow. This is outside the Grand Canyon. Again, looking out over the landscape, you see not a whole lot of vegetation. You see some shrubs, and that's about it. Zion National Park is also located in this area. Now, there is a river that comes through Zion National Park, and that can attribute to some of this vegetation. But what's interesting about this picture, this used to be a desert, much like the Sahara Desert. It was piles and piles of sand. And you can see how the wind blew the sand sort of back and forth. And this all got compressed, and this is now sandstone. This is more sandstone. You can see the layers of sand as it had been built up. Monument Valley in Utah is also part of the desert area. These are formed by different types of erosion, but looking out over the landscape, you don't have a lot of vegetation. This is more Monument Valley. This is also a very neat place, Monument Valley. I would suggest going there if you can someday. This is a famous part of Monument Valley called the Mitten, because it looks like a snow mitten. Here we were taking a walk through the desert. You can see the shrubs a little bit easier here, but we were going to what we call a slot canyon. We're about to enter the slot canyon here. Again, notice you get some shrubs here. We have a lot of sandstone, but not much else. This is my mom and me walking towards the slot canyon. Slot canyons form when it rains in the desert. The soil can't soak up a lot of the rain, so we get a lot of flash flooding. This is all sandstone, and the sandstone can get carved very easily by the water. So the water comes in, flash floods, and within seconds, you might be under 50 feet of water if you're caught in one of these floods. Here our canyon's getting a little bit deeper. That's my brother and myself. This is the age before digital camera and photography, if you can tell. But there are areas where the slot canyon opens up. So we camped on this hill. So if it were to rain, we'd be relatively safe. We'd be stranded and stuck until it was over, but we'd be out of the water. To give you a reference, that's my brother standing right there. So these walls can get maybe up to like 1,000 feet high. And we would have to walk once a day to get fresh water. So this was one of our walks to get our fresh water down one of the canyons. What's interesting with the canyons, sometimes the rain leaves puddles of water, and because the top of the canyons are very thin, even the bottom is very thin. You can see it's not very wide, so it only gets 5, 10, or 15 minutes of sunlight a day. So inside these canyons, even though we're in the middle of the desert, in the middle of the summertime, it might be close to 100 degrees on the top. Inside these canyons, it's like air conditioning. It's like 70 degrees. And the water down here, again, it doesn't get much much sunlight. So we measured it with our little thermometer, and it was just above freezing temperatures. So it was very cold trekking through one of these, what they're called cesspools. This is our road leaving. You can see our road kind of climbing up the hill over here. Again, notice the lack of vegetation. This is Great Sand Dunes National Park. The reason why we have these massive mounds of sand is because, notice this mountain range back here. So we have the wind, let's say, blowing this direction, and it reaches this mountain. The wind slows down enough to go up the mountain, and when it slows down, it can't hold the sand anymore. So it drops the sand, and we get these big piles of sand, and these are called the sand dunes. Mesa Verde is a Native American tribe that would make their houses and their buildings on the side of these cliffs. Humid continental climate. This is the east coast of North America and Asia. There's a large seasonal change, meaning we have really warm, humid summers. We get a lot of maritime tropical air mass, but in the winter times we get a lot of continental polar air mass, cold and dry. Humid continental is noted for its deciduous trees. Deciduous means the trees that change color in the fall and fall off. They lose their leaves. Evergreen trees are like your pine needle trees. They stay green year-round. We get about 75 centimeters of precipitation or rain. These are mainly due to cyclones, which are low-pressure systems that are storms. Humid subtropical climate. This is going to be the southeast United States, 30 to 40 degree latitude. These are noted for having hot and humid, especially hot and humid summers due to that maritime tropical air mass. And they get more rain because of that maritime tropical air mass, 75 to 165 centimeters of rain a year. Key West is an example. This is in southern part of Florida. This was Christmas Eve, and it was warm enough that we were in our bathing suits playing in the water and the sand. This is the mangrove swamps in the Florida Everglades. Notice the abundant amount of water available. These are more mangrove swamps. The plants, notice they've found a way to adapt to living in this flooded water. And birds typically have longer legs so that they can stand in the water. It can get very dense and thick in terms of vegetation. Okay, polar climates. Subarctic climates, this is like 55 to 65 degree latitude. Alaska has a subarctic climate. Typically they're dry because they're continental polar air masses, so 25 to 50 centimeters of precipitation of rain or precipitation a year. They get more severe winters and very short summers. They typically have spine and spruce trees, evergreen trees, because most of their precipitation is probably in the form of snow. So our deciduous trees, they're the ones that kind of look like this, and they lose their leaves. But what happens if we get a lot of snow? If we get a lot of snow piling up on our branches are going to break, and then our tree no longer has that limb and it becomes damaged. But if I look at a evergreen tree, a pine tree, it's going to have branches like this. Notice how my branches are tilted downward. So now if I get a bunch of snow on top of a branch, my branch can just bend a little bit and my snow is going to fall down and my branch is not broken. So these are better adapted for snowy conditions. Also with the needles, they have a waxy coating, so that's going to help prevent water loss in the cold, dry winters. This is an example of permafrost in Alaska. Permafrost means permanently frozen. So this house was built in a time when the ground was permanently frozen. Now with climate changes slowly occurring, our ground is no longer frozen and our buildings are now starting to sink into the ground. People have to adapt to the really cold winters. This is a parking lot, and you're supposed to plug in your car in the wintertime so it doesn't freeze while you're doing your grocery shopping. This is a steam vent to keep the underwater pipes warm so they don't freeze at night, or during the day for that matter. These climates are well known to have glaciers. So here's a glacier coming down and another glacier coming down and meeting it. A glacier is essentially a river of ice. It moves slowly and it carves out these U-shaped valleys. This is another part of Alaska. Notice all the pine trees, they're very thin and the branches tilt downwards. Again, notice how thin these trees are, so they can't have very long limbs because of the snow coverage. This is Newfoundland in Canada on the eastern part. Notice our foggy maritime polar air mass coming in again. You can see the fog as the air rises up these mountains. It becomes condensed and forms our clouds. This is a Viking landing and Viking village. The higher up you go, referring to the rain shadow effect, the higher up you go, the air gets spread out because there's less air pressure. Because the air spreads out, there's less oxygen per square meter. That means there's less oxygen for our plants, and notice how tall our plants are. They're probably only about 5 feet tall. That's because there's less oxygen to support them. And if you climb high enough, you get to become what's called above the tree line. Here, there's just not enough oxygen to support trees, so there are no trees at the top of really high mountains. The tundra. Northern parts of Alaska, the North Arctic Circle, can have areas of tundra. There are no trees in the tundra. The only kind of plants that we might have are moss. Lichen is a form of bacteria and fungus together. They're really good because they break down rocks and produce soil. And you might get some small flowering plants. The warmest temperatures typically reach about 4 degrees Celsius, and they're, again, in part of that high pressure system, so they only get about 25 centimeters of precipitation, usually of snow, per year.